All right, as you guys can notice, we have gone out of order. We did 9.5 first, and then we came back to this. The reason I did that is I wanted to go over all the different transformations and then come back to something called compositions. So today's lesson is called compositions of transformations. Okay, the first part says, what are the transformations we have discussed so far? One of them, anybody?
Reflection.
Reflection, sure. Reflection, translation, rotation, good, and dilation. Okay, these all had something in common. We talked about this in the last lesson. Those are all going to be isometries, which means the preimage and image will be congruent, whereas a dilation is the only oddball. That one shows that the preimage and image are going to be similar. Does anybody have any questions about that? Okay, a composition of transformations is just going to be two or more transformations back to back. Okay, now I want you to think about this. This talks about the composition of two or more isometries. Remember, an isometry makes the preimage and an image congruent. Let's say you did a reflection, which is an isometry, and then you did another isometry, let's say a translation. If you did those back to back, what will you get in the end? You do two or more isometries, you end up with a what? If you took this figure right here and you reflected it, and then you translated it, what do you notice about these two figures? They are congruent. So two or more isometries together will give you still a congruent figures or an isometry. So you can do like 50 different reflections followed by 20 translations followed by 10 rotations. And in the end, as long as you don't mess anything up during the process, the original figure and the end figure must be congruent. And it's kind of like the transitive property almost. Does anybody have any questions on that? Lovely. Next, the composition of reflections. The composition of reflections over parallel lines. Now this one is a little interesting. Take a look. We've got parallel lines here. It's called, this one is line L, this one is line M. If I reflect A, B, C over the first line, and then I do it again, if I covered this up with a piece of paper, as in you couldn't see what happened in the middle, what does it appear that two reflections over parallel lines just gives you? A single what? Translation. Fantastic. The composition of reflections over parallel lines is a translation. Anybody have any questions on that? Now, this is how you show a composition. That little dot means composition. Now, the really weird thing here is our brains always want to read from left to right because that's how we read books and that's how we've been trained. But actually, when you are completing these things, you are going to do it from, it's not going to be left to right, it's going to be right to left. So just be careful with that. And the reason being is, I guess you haven't done this because you haven't been in Algebra 2 yet. If you had something like this, P of K of X or something like that, you work from the inside outwards. You would do what's on the inside first and then go outwards. And that this is kind of like a different way of writing that. But just know you're going to go from the right to the left. That's the biggest thing people mess up on here. Other than that, it's, hey, do you already know how to do all these transformations? Yes, then can you just do them back to back? So as you can see, a reflection over one parallel line and then over the other one is going to be the same thing as a translation. Does anybody have any questions on that? This should make sense also. What happens to the orientation after we go over and reflect over one line? Orientation changes, it flips. Okay, it's the exact opposite. But you're like, wait a second, that makes no sense because the translation is not allowed to flip. Well, if you flip it and then you go over and reflect again, what happens? Good, it goes back to the same. It's kind of like multiplying by a negative number. Multiplying by a negative makes it negative. Multiplying by a negative again makes it positive. So two reflections will flip it and then flip it again, which makes the orientation the same. Question. Fantastic. So you go over and you do the first one will be prime, the second one will be double prime, the next one will be triple prime. Mathematicians are crazy, lazy, and efficient, and that's the most efficient thing you could do. Does anybody have any questions on that? Okay, let's go ahead and do some practice here. It says that you are going to do a reflection. Let me see if I can zoom in a little bit. Yeah, there we go. Okay, we are going to do a reflection over two different lines. Does that say x equals what? The first one on the right hand side. 1, okay. And then this one is x equals 8. Okay. Now, rather than doing all the points, let's just do A, because if you can do A, you can do all the rest of them. Now, this is a little tricky. You are going to be reflecting over a vertical line and over a vertical line again, in this case. If you took a point and you reflected over a vertical line and then you reflected over another vertical line, what coordinate does not change, the x or the y? The y. So if we're looking at this point, A is negative 5, 4, we know a double prime will have a coordinate of what? We just said that the y does not change. So which part do we already know? It's already 4. Okay. Now the hard part is going to be to figure out what the x is going to be. So let me show you the way I do it. You guys can do it graphically, or you can do it the way I do it. So I know I have to figure out the distance from negative 5 to 1 and figure out what direction I'm going and then go the same exact direction. So if this was like 3 units away to get to the line of reflection, I would do another 3 units to get on the other side. Does that make sense? So if we have the number negative 5, and I'm trying to find out how far is that from 1. How far is that from 1? What do I have to do? Do I have to add something or do I have to subtract something to get to 1? Add how much? Add 6. So then how do I go away from that line of reflection? I'm going to add 6 again. So where's the new location? 1 plus 6 is 7. So A prime will have an x coordinate of 7. Now we have to do it, flip over the next line. How far is 7 from 8? What do I have to do? 7 going to 8. Add 1. So what am I going to do to go away from the line of reflection? Add 1 again, and that puts me at 9. A double prime is going to have A double prime is going to have a x coordinate of 9. So once again, try to figure out, sometimes it's going to be reflect over x, then reflect over y. So maybe at first, the y doesn't change, and then the x doesn't change. It gets a little bit confusing. Does anybody have any questions on that one? Can you guys read off this to me? What does that say? X equals, and the other one is x equals 5. Okay, I'm just telling you right now on your homework, you're going to have an x equals 1 and then a y equals 1. So you're going to have to flip it over the x, and then you're going to have to flip over the y. So let's do the same thing. Let's save time. I am going to pause the video for people at home to go over and try this problem. And then people in class, go ahead and try to do this one. Figure out what is going to stay the same, if anything. And then figure out what the point becomes to be A double prime. I'm going to pause the video. People at home, go ahead and try it. Okay, on this problem, once again, it's flipping over 2 vertical lines. So it'll flip over one and it'll flip over the other, but we could say the y coordinate is going to stay the same. So y is going to stay as 4. Now we're at negative 5, and we're going to jump over 1 first. So how far to get to 1? I'm going to have to add 6. So what do I do again? I add 6 again, and that gets me to 7. Now we're at 7 for A prime. I now need to jump over 5. Well, how do I get to 5? Subtract 2. And if I subtract 2 again, I get 3. Now, once again, in your homework, you are going to have like a jump over that one and then jump over this one. And what you would do is you're going to figure, okay, at first, it's a little bit more work because you're going to have first, it's going to have the y stay the same, and then you're going to flip over a horizontal line, so the x will stay the same. Or, yeah, x will stay the same and y will change. Does anybody have any questions on how you would do that? Okay. All right, let's take a look at the next one. The next one says the composition of reflections. Put your phone away. Composition of reflections over two intersecting lines. What does that appear to do? If you reflect over one line and then you reflect over another line, they're not parallel because that would have given me a translation. What does it appear you end up getting? What's that? So I see what you're saying. You're saying it almost looks like a reflection. Good. Okay, let's go really quickly. She said reflection. It's good sometimes when we get an answer that's not correct because we have a chance to discuss it. What would be true about the original and the double prime if it was a reflection? What would have happened to the orientation? The orientation would, for a reflection? When you reflect, doesn't the orientation flip? Okay, so if this was just a single reflection to get from here to here, the orientation would have had to switch. What that means is if you start with A and you go clockwise, it would have to be the exact opposite when you went A and went clockwise over here. A clockwise says ABC, going clockwise. Over here, if we start with A and we go clockwise, what do we get? ABC. Did the orientation flip? No, it did not. So if the orientation didn't flip, then it can't be thought of as just a single reflection. Thank you for bringing that up, though. So if we reflect once and we reflect again, that looks to be the same as a single what? Rotation. Good. But it's important for you to think about that. Like, okay, is this just a reflection? Because it totally looks like it could just be a reflection over this line right here. But if it was, then the orientation would have flipped, and the orientation did not flip. So if we look at a problem like this and it says, the following figure is reflected over two lines that intersect making 80-degree angle. What is the total angle of rotation that you would have gotten? So they're saying that this is 80 degrees over here, and we want to figure out how many degrees we're going to get. So let's go ahead and pretend, let's just split this up. Let's say this was 30 and 50 degrees. If you reflect over this, and this one was, try to get a different color, black. If this is, Mamma Mia. If this one was 30 degrees, then what would this one be over here? Knowing it's a reflection. Look at like a point when it reflects over something. It would go from here, it'd be 30. Whatever this angle is the same as that. So if this is 30, then this one would be 30 as well. If this was 50, then what would this one be? 50. And what do we get when we add all those up? 160. And it doesn't matter if this was 60 and 20 or 70 and 10. It doesn't matter how we split these up. You'll still end up having whatever is outside will be the same thing as what's inside. So in this case, it's 160 degrees. Does anybody have any questions on that?
Can you just double?
You can. Yep. All right. The next one is a glide reflection. If you had to guess, a glide reflection would be what followed by what?
Translation.
Great. So a translation is the thing that is closest to a glide. So that is a translation. So a glide reflection, they call it a single transformation basically, but it's the composition of a translation followed by a reflection. And here would be your example. You would translate 1, 2, and then you would follow that up by a reflection over y equals 5 or something like that. That would be a glide reflection. And that kind of explains why you do the thing on the right first. Or if you ever forget, oh, this is a glide reflection because the glide is over here. We are going from left to right. Nope, right to left. Oops. Does anybody have any questions for that? So let's say we are doing a glide reflection right here. The first thing says we are going to glide 0, -5. So that means what? student sitting right in front of me. You.
Go down.
Go down by how much? Great. So we're going to take these points and we're going to go down by 5. 1, 2, 3, 4, 5. It's here. Now you could take all the rest of the points. I'm just going to be lazy and efficient and go, okay, I know it's up by 2, over by 1. And then it's down by 2, over by 2. So that would be the location of T prime, E prime, X prime.
Mhm.
And then now it says reflect over X equals 0. X equals, is that vertical or horizontal? Vertical. So that's going to be a vertical line going through 0. So we go over here, and that's our line. And now we just need to reflect over it. So this is 2 units away. I'm going to go 2 units away and put X double prime. This is 1, 2, 3, 4 units away. I'm going to go 1, 2, 3, 4 units away, and I'm going to call that T double prime. And then you can figure out the distance for E. I'm just going to say it is 3 units away from X. 1, 2, 3. And that's E double prime. Some people like to shade it in afterwards, just to say that's my final. Any questions? Okay. Now these are a little tricky. For some reason, people struggle with these a lot. If I'm telling you to reflect over these two, we know that a reflection over 2 intersecting lines will be a what? Anybody? Rotation. So we better get a rotation in the end. So what you can do is you are supposed to go the distance from A to your line perpendicularly and go the same exact distance and put your point A prime. Go your distance to C. I don't have a ruler with me, so I can't do this using a ruler. I would go the same distance and put C prime. I go the distance to B, and I'd go the same distance, and that would be where B prime is. Once again, mine's not perfect because I'm having to wing it without a I'm having to wing this without a ruler. Now, people always mess up. Remember, this has to be perpendicular. Make sure it's perpendicular. And then when we're done with that, we're going to go over and figure out the distance from C. We're going to go the same exact distance and put C double prime. Figure out the distance B, go the same distance and call that B double prime. And the distance A, go the same distance and call it A double prime. And this was an isometry followed by an isometry. So what should be true about ABC and about A double prime, B double prime, C double prime? They should be, if it's 2 isometries back to back, what's true about ABC and A double prime, B double prime, and C double prime? They should be congruent. As you can see, mine are not perfectly because I had to wing some of the distances. Anybody have any questions on that? Okay, if you guys got that, I would like you to go over and try this one right here. I'll pause the video. You guys try it at home as well. All right, people at home, this is what yours should look like. You should make sure that the distance from A to the line of reflection is equal to the distance from the line of reflection to the A single prime, and make sure that these are perpendicular. Those are perpendicular, and these are perpendicular, and then these ones as well. And as long as you did that, this is what it should look like. And 2 reflections over parallel lines should give you a, anybody? Translation. Fantastic. Okay, one last problem. Go ahead and pause the video. People at home, try to do this glide reflection. See if you can do it. Okay, on here, just make sure that you guys are going from right to left, which is kind of strange, but you're going to get used to it. So the first thing you're going to do is you're going to go left by 4 and down by 4, which I did, and that got me to T prime, E prime, X prime, which is my red figure. And then I reflected over Y equals -2. You got to be careful with Y equals versus X equals. So in this case, Y equals -2 is a horizontal line. I drew it. Any points below went above. Any points above went below. and you can see my final blue object here, which is the double prime. Questions? All right, cool. Thanks for watching. Homework is on the back page. Get her done.